Coulombs Law. In this module, you will learn about the Coulombs Law. You may have observed that if you rub a balloon on fur and then hold it against a wall, amazingly, it sticks to the wall. This implicates that there is a force holding it onto the wall. This electrostatic force between such static charges can be given using Coulombs Law. To understand the electrostatic force, consider two pith balls with equal charge hung from a clamp. The balls get separated by a certain distance. Next, when we double the charge on each pith ball, separation becomes 4 times. This observation leads to the development of Coulombs Law. Coulombs Law states that the force between two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the two charges. The Coulomb force acts along the line joining the centers of the two charges. The Coulomb's force has a constant of proportionality K, where K is equal to 1 upon 4 pi epsilon 0. The value of K is 9 into 10 raised to the power of 9 Newton meter square per square coulomb. Epsilon 0 is the absolute permittivity of free space, which is equal to 8.854 into 10 raised to the power of minus 12 Coulomb square per Newton per square meter in SI system. To understand vector form of Coulomb's law, consider 2-point charges Q1 and Q2 at R1 and R2. The vector R21 from Q1 to Q2 is equal in magnitude but opposite in direction to the vector R12 from Q2 to Q1. On analyzing the Coulomb's law, the force on charge Q1 due to Q2 is given by F12 equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square R12. Similarly, the force on Q2 due to Q1 is given by F21 equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square R21. The two forces are equal in magnitude but opposite in direction. Another observation of the Coulomb's law is valid for charges that are either positive or negative. The equation F12 equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square R12 gives the magnitude as well as the direction for both positive and negative charges. The direction of force can be defined from the chosen coordinates. On analyzing the Coulomb's law, you can observe that the force acts equally on each point charge, however in opposite directions, even if the charges are unequal. Hence, two forces constitute an action-reaction pair. Another observation is that the Coulomb's force acts along the straight line joining the two charges from the centers. Therefore, the electrostatic force between the two charges is central in nature. The last observation from the analysis, however simple, is that like charges experience forces acting away from each other, and unlike charges experience forces acting towards each other. In this module, you have learned Coulomb's law defines that the force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Electrostatic force between two charges is central in nature. The force on charge 1 due to 2 is equal to the force on 2 due to 1, but in the opposite direction, forming action-reaction pair.